Hi, welcome on Jim's Orbit. It's the part 6 of the video series for the chapter Real Number. We have covered till part 5. We have covered the problems based on SCF and LCM. Those were the word problems and it was one of the most important part. So do not forget to watch part 5 because that will come in your exam. Okay. And now in part 6, I'm also taking the most important questions on divisibility and also the most confusing topic so far. As far as I have seen students, they lot of time get confused in this. Okay, so what we will do, we will understand this by a very simple approach. I will give you some rules and then what you do in this video, just pause this video, write down those rules on a sheet of paper and then start solving the problems, because I mostly will be taking the rules and then I'll be telling you again and again that okay, I told you in that sheet. So rather than skipping the video, you just can write it down on your on a paper on your notebook, and then we will be able to solve it much easily. Fine, and I'll try my best to explain it to you, and I hope that you will understand this topic. If in case you were not able to, just please ask me that in the comment box. Okay, so let us begin with the rules. Okay, these are the only 6 types of problem that are there in your syllabus. Okay, very simple. There's a type of question is written and in the opposite side the approach is mentioned. Okay, now let us try to understand each of them one by one. I'll try to take a simple example if it is possible. Otherwise, I will try to make you explain in the question only. Okay, the questions will be coming in the after part of this videos. Okay, one thing I'll also do, I'll also explain in Hindi a bit. Okay, so that it is easy for each medium student. Okay, let us start. Question 1. Find the least number which is exactly divisible by xyz. So in this question, what you will see there is a number which has to be divided by x, y and z. These numbers will be given to you. Okay, in this question we always take the LCM. That is the answer. Finish. Nothing else you have to do. Okay, now what it is saying, find the least number. Like suppose a number, it is divisible by 2, 3 and 10. Okay, which is the number which can be divided by 2? It should be in the multiple of 2. 3, it should be in a multiple of 3, and 10, it should be a multiple of 10. Obviously, if the number is a multiple of each of these numbers, then we have to take the common multiple, and we have to find the smallest number. So it should be the lowest common multiple. Hence the answer is 2, 3, 10 LCM. We can directly find it. Is just see 2 and 3 are prime numbers, so their LCM is 6, and hence 6 and 10 LCM is 6, 10 3s are 30, 6 5s are 30. So it should be 30. Okay. Hence the number which is divisible by both all the numbers 2, 3 and 10 is 30. So जिन भी नंबर्स में ये पूछा जाए कि एक ऐसा नंबर बताइए जो कि किसी 2-3 नंबरों से डिवाइड हो सकता हो, तो आप हमेशा उस क्वेश्चन में एलसीएम ही लिया करेंगे. ठीक है. Let us read the question number 2, type 2. In this question it is written, find the least number which when divided by xyz leaves a remainder r in each case. Now this, you understand this. Okay, it is getting divided again, so this part is the same till this, divisible or divided, they are same thing, and you have to divide this. So suppose it was 30, so 30 was completely divisible by 2, 3 and 10. Now we are saying no, you need some remainder. Suppose the remainder has to be like 5. Okay, so if you need 5 to be the remainder, you should have more than this. So the answer should have been 35. The rule is simple. Use the LCM, find the LCM and then add the value which you want to get as the remainder. तो जब भी आपको ऐसा क्वेश्चन पूछा जाए जिसमें आपको ये कहा गया हो कि किसी 2-3 नंबरों से डिवाइड करने पर एक ऐसा नंबर आए जिसमें कुछ हमेशा संख्या बच जाए, तो आप उसमें हमेशा एलसीएम निकाल लीजिए और एलसीएम निकालकर उस जो बची हुई संख्या जो बच रही है उसे जोड़ दीजिए. तो इससे आपका सबसे छोटा नंबर आ जाएगा जो कि उन सभी से विभाजित होगा. ठीक. नेक्स्ट, क्वेश्चन नंबर 3, टाइप 3. इन दिस क्वेश्चन, find the least number which when divided by xyz leaves remainder A, B, C respectively. This is the most typical of all. इसे ऐसे समझते हैं कि जब हम किसी नंबर को जब डिवाइड करें x, y और z से, तो हम रिमाइंडर एक ही चीज नहीं बचे, बल्कि कभी a, दूसरे वाले में b और तीसरे वाले में c बचे, तो उस समय वो नंबर क्या होगा। ये सेम क्वेश्चन मैंने अपने मिसलेनियस सीरीज के क्वेश्चन 4 में किया है. There is a set of miscellaneous problems I have uploaded and I have done the same question as in the question number 4 of that video. You can watch that video. It's a separate part, okay, I'm dealing with. So you try to watch that video, you'll understand there also now. Otherwise, I'll take this concept in the question itself. I'll not be taking directly right now, okay? Don't worry about it right now. Okay, question 4. Find the greatest number that will exactly divide xyz. Now this is, if you see, this is not double line, nothing is there. This was the LCM case, now it's the SCF case. If the number is dividing some other numbers, now this time find the number that will divide xyz. So read this line just. It will divide, it was here divisible. If it is divisible or divided, we find the LCM. If it is dividing some other number, we find the SCF. So the number that can divide 10, 15 and 20. What is the highest number that can divide? Obviously it is 5 and 5 is the SCF. Okay? तो वो संख्या जो कि एक तीन अलग अलग संख्याओं को डिवाइड कर सकती है या विभाजित कर सकती है, वो संख्या हमेशा SCF कहलाती है, हाईएस्ट कॉमन फैक्टर होती है उन्हीं सभी नंबरों का. ठीक है. क्वेश्चन नंबर 5. फाइंड द ग्रेटेस्ट नंबर that will divide x, y, z. Again, it is still this part, this is the same. So you find the SCF, but the problem is they are saying something else, leaving the same remainder. So you want the remainder to come up. Obviously, if you are going to divide a number and if it remainder is left out, that means that it is not getting completely divided. It can only be completely divided if we subtract that digit from it, subtract that number from it. Okay. So like 12, 17 and 22. Simple. These all are divided by a number and leave the same remainder 2. Okay. So 2 is left out. If it was not here, it would be completely divided. Hence the number was 10. Here it was 15 and here it was 20. So we have to find the SCF of this 10, 15 and 20. What it is? 5. So the question is simple. You always want to find the SCF of the numbers after subtracting the remainder from those numbers. जब भी आपको कभी कोई ऐसा नंबर पूछा जाए जो कि तीन अलग अलग नंबरों को डिवाइड करता है और कुछ रिमाइंडर बच जाता है, तो उन नंबरों में से उस रिमाइंडर को सब्ट्रैक्ट करके आप SCF निकाल दीजिए, आपका आंसर आ जाएगा. Question 6, last type. Find the greatest number that will divide x, y, z, leaving the remainder a, b, c respectively. अगर संख्याएं x, y, z डिवाइड हो और रिमाइंडर एक ही चीज ना बच के अलग अलग संख्याएं बच जाएं, पहले में a, दूसरे में b और तीसरे में c, कोई फर्क नहीं पड़ता, हमको अभी भी उस चीज को सब्ट्रैक्ट कर देना है, तो बस हमको उसको सब्ट्रैक्ट कर देना है और SCF ले लेना है. क्योंकि तब सही बात है, अगर यहां 13, 18 और 27 होते तो इसमें 3 बचता है, इसमें 5 बचता है और इसमें 7 बचता है. अगर हम ये हटा दें तो हमारा सीधे आंसर 10, इसमें 8 बचता है मान लीजिए, तो 10, 10 और 7 20 हो जाएगा और इसका आंसर आ जाएगा SCF सभी का 10. ठीक है. So the number that will divide these three numbers, you're going to do the same thing. You are going to subtract this remainders from each individual numbers and hence then you are finding the SCF. Okay. I will take now each and every problem in detail. Okay. Let us start. First, find the smallest number which when increased by 17 is exactly divisible by both of the two numbers 520 and 468. See, you forget this line, okay? Just leave this line. What is written here? Find the smallest number exactly divisible by two numbers. Come back again. find the smallest number exactly divisible by these numbers. We have to take the LCM. I hope you have written it down on your sheet of paper. Okay. So exactly divisible by these two, we will find the LCM. Directly it is now. Okay. And obviously you are going to find a number which this can divide and this can divide. And I told you in the last video, in the part 5, that if the answer is that is going to be bigger than the numbers, we find the LCM. So the answer is going to be bigger, hence we find the LCM. Do not worry about this, we will solve it later. So now you've got the LCM of these two, and we have understood, we have followed a process, so we can just do the prime factorization, but this is like division. Okay, so 2, 2 to the 4, 2 6 are 12, 0, 2 to the 4, 2 3 the 6, 2 1 the 2. Okay, so far it's fine. So now we will do for 2 again, 2 1 3 0, we get 231. Okay, still it's going by 2, so 2 6 12 65, 231. Okay, it's not gone by 2, so let us check for 3. So 3 65 won't go, but this will go. 3 7s are 21, 3 7s are 21. Okay, again 3 will not work, 5 will work. So 5 13 77, copy paste. And now the 7 will work, 13 11, and now 11 will work, 13 and 1, and now 13 will work. Okay, so we have found the LCM. The LCM will be, what will be the LCM? Multiplicand of all these numbers. So 2 into 2 into 2 into 3 into 5 into 7 into 11 into 13. Now I have told you again and again, keep this 5 and 2 as same. Okay, keep this separate. So it will be 10. Now solve for the others. So 2 to the 4. Okay, 4 3 is a 12. 12 7 is a 84. Now 84 into 13 we will do. So 84 into 13 we will do. Fine. So this will give us 2, 9 and 10. So 1092. And still 111 is left. So it will be like, we can directly do this. Just copy this one, copy this 2. 9 plus 2 11. 1 carry. 9 plus 0. 9 plus 1 10. 1 carry. So 1 plus 1 2. So the answer is 1 2 0 1 2, and 5 2s are 10, so put a 0 here. Simple. Now it was not saying directly divisible, it was saying like you are going to divide, it is divisible, okay fine, but it has to be increased by 17. So if it is going to be increased by 17, it should have been less than by 17, then only you can increase, and that will be the answer, correct? So we will say that the answer is 120 it should be less than 17. Then only when you increase by 17 it will become this, and it will get perfectly divisible. So this will be 120, so 0 1 0 3. Okay, 20 minus 17 is 3, so this is our answer. Simple. Okay, I hope you have understood this. Let us take the next problem. Okay, question 2 says, find the smallest number which when diminished by 17, diminished means reduced, okay, by 7, sorry, reduced by 7, it is divisible by all these numbers. Again, it is divisible. Divisible means LCM. LCM of the numbers first of all, and then afterwards. So LCM of 12, 16, 18, 21 and 28. Let us start solving them. So 12, 16, 18, 21 and 28. So we will get 2, 6 are 12, 8, 9, 21 and 14. Okay, let us do the next one. 2, 3, 4, 9, 21 and 7. Now 2 will work here. It's still 3, 2, 9. All the numbers are just copy pasted because 2 can only divide just this, nothing else. Okay, so we will have this. Now 3 will work. So 3 1 1 3 7 7. Now again 3 will work. So 3 1 1 7 7. Okay, so this will be now 7 1 1 1 and 1. Okay, So we have found the LCM is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7. That is the answer. So it is 2 to the 4, 4 to the 8, 8 to the 16, 16 into 9 is 144 and multiplied it by 7. So that will be 1008. Okay. So 1008. This is the LCM. Okay. Now what the question was saying, it is going to be divided, but it when diminished by 7, when it is reduced by 7, then only. If it is going to be reduced by 7, it has to be more than by 7, and then we will reduce it, we will get this. So our answer here will be 1008 plus 7. When it is saying reduce, add it, like it's just opposite you are doing. Okay, so you get 1015 as your answer. I hope you have understood this. Simple problems. Okay, don't worry about it them much. Okay, just try to understand them by playing the video again and again. If you didn't get it, then please do post in the comment box. I'll try to explain it further there. Okay, now the very important question. It has been asked twice, thrice in the paper, so read it carefully. It's saying find the greatest number of 6 digits exactly divisible by 51, 68 and 42. The number has to be divisible by, divisible means LCM. Divisible means LCM, direct. So we are going to find the LCM. Now LCM of all these three numbers. Let us start finding. Okay, so 2 will work. 3, 4, 2, 1. Okay, now 2 will again work. So 51, 17, 21. Now 3 will work. 3 ones are, 3 sevens are. 3 sevens are. And now 7 will work. This is 17, 17, 1. And now 17 will work. Okay. Now we will write the LCM. So the LCM is the multiplicand of all these values. So 2 into 2 into 3 into 7 into 17. So 2 to the 4, 4 to the 12. 12 7 is 84. So 84 into 17. Okay. Let us do that separately here. 84 into 17. So it will be like 7 to the 28, 8, 2, 7 to 56, 2, 58. Okay, 4 and 8. So 8, 8, 4, 12, 2, 1, 8, 6, 14. I hope I'm correct. Okay. You also check. I can also make mistakes. Fine. It's fine. Okay, then it's right. So we will write 1, 4, 2, 8. That is the LCM. Now, that is again not saying the same thing. They will not ask you such simple problem. Yeah. So let us read the problem again. The greatest number of 6 digits. Now we know the highest number of 6 digits. It is 999999. But it has to be divisible by this or by the LCM of them. So we have got the LCM. So rather than dividing it individually by each one of them, we will divide this by the LCM of this. Okay. Okay, this is a lot of practice now. So let us start. 14289999. We will take 4 nines. Now obviously, if 14 sevens is 98, it is like 98 is 7 times is the limit. Okay, so let us check into 7. I'm doing here only. 7 8 56, 6, 5, 7 14, 5, 19, 1, 7 4, 28, 9, 2, 7, 7, 2, 9, 9, 9, 9, 6. I hope we have achieved very clearly this. I just saw 14 7 ja 98 and it was lesser than this. Okay, so 9996. Subtract this, we will get 3 only. Copy this, 39. Okay, now is it 39 divisible? Is 39 divisible by 1428? No. So after you are going to write this 9, so you are going to put a 0 here. Okay, now again check. Is it divisible? No, you put a 0. So you get 0 0. Again you get 399. This is very simple. You must have completed this. Whatever you have got as the remainder, it's the extra value. If it was not here, we would have got completely divisible by 1428. So what we have to do? We have to subtract this. Okay? We have to subtract 399. This is we have to do. I hope you have understood this. So I'm going to subtract it. Okay? Let us write. So the answer divisible by this. So the answer is this coming extra should not be here. So 999 minus 399. It will be 0, 0, 6, 9, 9. This is our answer. We got it very easily. Okay, but sometimes it can go beyond. I have just looked this number. It's quite tricky. Okay, do not get confused. We are going to subtract this. I hope you have understood so far. I'm moving very slow. Okay, so in case I'm moving fast, do let me know in the comment box. Let us now jump to the next part. Now the question says, what is the smallest number that when divided by, divided by this, leaves remainder of 8 in each case? It's a direct property. See, find the smallest number which when divided by x, y, z leaves a remainder in each case. Divided, LCM. Remainder is left, find LCM, add R. I have just explained it here already. Correct? So see how easy it is now. Come back. So we will find the LCM and add the remainder. Direct. Divided, LCM. You have to find the smallest number. We are going to take the LCM. Just LCM. Remainder is left. Add that. Okay. So this is 12, 15, 20, 54. Let us find the LCM. 2, 6, 15, 10, 27. 2, 3, 15, 5, 27. Now 3 will work. 1, 5, 5, 9. Again 3 will work. 1, 5, 5, 3. Again 3 will work. So 1, 5, 5, 1. 5 will work. 5, 1, 1, 1. So now LCM is what? What is the LCM? LCM is 2 into 2 into 3 into 3 into 3 into 5. What I have told you again and again, you have to keep 5 and 2 as a pair. So 5 2s are 10. Leave them. Okay, leave these two. 2 3s are 6, 3 3s are 9, 6 9s are 54 and 10. So it is 540. So 540 is the number which is getting divided each by. So 12 can also divide, 15 can also divide, 20 can also divide, 54 can also divide. But they will completely divide it. But you want remainder. Obviously, if you want remainder, it should be extra there, na? Yeah, correct. So you just add it also by the rule and also by the concept. So the answer is LCM plus the remainder. So the answer is 548. How easily we get it? If we have remembered the concept and the rule. Okay. Let us just take the next problem. Here comes the utmost typical problem. Okay. It says, find the smallest number which leaves remainders 8 and 12 when divided by 28 and 32. Now you just come back here and see what was the rule. If a number is least and it is divided by some numbers, you have to check whether the difference of this x and the remainder for each number pair is same or not. If it is same and it is equal to k, you are going to find the LCM and subtract this k. I'll explain you. I have already done this in the miscellaneous. I'm again telling you, but I'm going to do it on this same question number 5 here. Okay. We are going to check whether this difference of the number and the remainder are same or not. And if they are same, we are going to consider that as k. And we are going to find the LCM and we are going to subtract this k. Okay. Let us come back. The question is, they leave the remainder 8. So the number is divided. Divided means LCM, direct. So 28, we have to check. 28 minus 8, is it equal to 20? And 32 minus 12, is it equal to? Okay, 20. So both are 20. This implies k is 20. Say means let k is 20. Okay. So what is the rule? LCM of 28 and 32, and then we have to add. First we have to find the LCM. So 28, we have to subtract. Okay, sorry. So 28 and 32, we are going to find the LCM. So 2, 1, 4, 16, 2, 7, 8, 2, 7, 4, 2, 7, 2, 2, 7, 1, and 7. Okay. Okay, so we are going to find the LCM. The LCM is 2 into 2 into 2 into 2 into 2 into 7. Okay, so it was so many times. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 7 the 7 to the 14, 7 to 21 and 22, 224. Please do check. Okay, I might be wrong, but please do check. Okay, 224, is it correct? Okay, now we have read that the answer is the LCM minus this value, which is the K value. Okay, so 20, so it is 204. Okay, now it was just simple. Now I'm going to explain what happened. Listen carefully. If it says that it leaves remainder 8 and 12, so let us divide this 204 by 28. So 28, 7, 8, 9 2 is 18. It is very high. So 28 7s are 7 is 56, 6, 5, 7 to 14, 5, 90. So we will get 8. Have you got 8 as the remainder? Correct. So have we got 8? Okay. So now think, like 204 is not completely divisible because it is having 8 more. Correct. Or you can say if it was having 20 more, then it would have been completely divisible. Correct. Yeah. If it was like 20 more, then 28, here we will get 20 more. So we will get 28. Yeah. And 28, if it is, so 28 ones will become 28. So it was completely divisible. But what happened is this, that it is lacking 20. Okay, so if it is 20 less, then it will work. And how you can get 20? 28 minus 8, that is we are subtracting. Same is for 32. If you have done 32 also, you will notice that 32 is 6 times. 6 to the 12, 16 is 18, 1, 19. Will give us 12 remainder. And we want 12 remainder. And because if it was 20 more, again it have become 32. And it will become completely divisible. Okay, so 20 is not there, so it is like 20 less. So whatever you are getting LCM, you should subtract what is the difference between these two, 32 and 12. Okay, so what we have to do, we have to subtract 32 and 12. Okay, and then we will get the answer. So this is what we are going to check. I hope it is much clear, although it is quite confusing, I also know. But if you remember this, that you are going to find the LCM and subtract K, then it will be easy. Okay. So let us do the last number. Okay. Question 6 says, find the largest positive integer that will divide. Now this is divide. When it is divided or divisible, we write LCM. But when it is divide, we write SCM. So it's saying largest positive integer that will divide these three numbers, leaving remainder something. Let us come back from the rule sheet. Greatest number that will divide, leaving remainder this. We always find the SCF. I have explained it to you here only. Let us come back. So if it is like there is a number that will divide this, this and this. Obviously, if it is dividing these, that will be less than these three, or at most equal to the smallest one. So the answer would have been the smallest answer. The smallest is the SCF. I have told you in the last video. So if it is like going to divide these three, it is going to be their factors, and hence it is going to be their common factors. It is the largest positive factor, so it is the highest common factor. So it should divide 398, 436 and 552. But it is not dividing here completely. It is leaving some remainders. So if they were not there, it would have completely divided it. Hence, we should subtract them first. 1, 9, 3, 11, 5, 2, 4. And now the 15. So 7, 2 and 5. So we are going to find the SCF of 391, 425 and 527. We are going to find the SCF of these. So it is very simple. We have already covered so much now. We can take any two numbers first and then we will find their SCF. First of all, okay, so 4, 3, okay, 34 is fine. So 391. So we have to reach at most 391. So 34 10 is 340. 34 11 will be 374. Okay, so 11 times will come. 374. So 7 1. 17 is coming. So 17 2s are 34. So 17 is the SCF in the first part. Okay. Use this 17 as your first SCF with your left out number, which is 527. So 17, let us check for my maximum. 17 3s are 51, 17. So 31 times it will completely divide it. Okay. Hence the SCF is 17 and that is the answer. We do not add or subtract anything in the SCF. We all together subtract in the question also. Only. See, in this C, we are finding the SCF. We are not adding or subtracting anything to the SCF. So we are going to find the SCF of the numbers after subtracting the remainders. Okay. This is what we are going to do. If they were not there, obviously we would have just been able to completely divide them by a number which was their SCF. But since the remainders are there, we should subtract them first and then find the SCF. It's obvious, okay? So this will complete every part related to the largest positive numbers and smallest numbers and so on. I have tried my best to explain this to you. But if I'm not able to explain it much better to you, please do let me know in the comment box, and do not hesitate in pressing the dislike button. I want you to press the dislike button rather than pressing those like buttons. I feel like I should get more and more better in explaining topics to you. Okay, but do not press the dislike button like knowingly. Yeah, even if you have understood that. Okay, fine. So that will just leave me quite disheartened. Yeah. So I will hope that you understood this all. Okay. And in the next video, we will start how we can prove the numbers are rational or irrational. That is also a very important concept. Okay. So far we have covered a lot of topics. If you have not watched those videos, please do watch those videos from part 1. You will try understand much better these things what I'm doing here. Okay, and thanks for watching again. Bye.